And factoring, when we have it in this format, this x squared plus bx plus c, and we're going to talk about now what these letters represent. The A, B, and C all represent numbers. So your A, B, and C are just, not number one, just are numbers. Now we've been factoring to where you've seen this, x squared plus bx plus c, meaning that A term equaled 1. Well, now you're going to see other numbers besides just 1 or no number in front of the x squared at all. So your A, B, and C, these are just the coefficients or the constant. So for example, if we have the problem like this, 4x squared plus 13x plus 3, the A term is 4, the B term is a positive 13. Remember that sign goes with it, so that's positive 13. And the C term is 3. So when we talk about A, B, and C, we're talking about the coefficients in front of the x squared, the x, and then this constant term. All right, so I just wanted to clarify that. When you see a problem like this, x squared plus bx plus c, meaning the coefficient in front of that is always 1. And that's what we were doing in 7.5. We're factoring the factoring when the coefficient here is 1, but now it's going to change. So looking at your book, you should have your book open the same page, 392. We're going to look at factoring out what we call the GCF. So the first step, so this is example 1, and when it says to factor 5x squared plus 15x plus 10, the first thing I want you to do is always look at your problem as a whole and see if there's any way you can make it a little faster. And if you notice, each term here, 5, 15, and 10, they all have something in common. They all have a factor of 5. So one thing you can do to make this easier is to go ahead and pull what we call the GCF, the greatest common factor, which we've done before, out of each of these terms. But notice the 5, okay, you can pull a 5 out of each one of these, but what about the x's? This is x squared, this is x, and there's no x here. So they don't have an x in common in all three. So we can factor out a 5. So it's like dividing, undistributing that 5 in each term. So if you divided this by 5, you have x squared plus, now 15x divided by 5 is 3x. Then 10 divided by 5 is 2. Now you can factor, now it's back into this format to when you have just 1 as your x squared. Okay, so you still have this 5 here, you can't drop that, but you have this, but now we have 2 binomials. And so now you have to remember how to factor that. So you can think of, okay, what 2 numbers multiply to get positive 2, but add together to get 3. Since those are both positive, we know that these have to be positive. So what 2 numbers multiply to get 2? The only factors of 2 are 2 and 1, so this is kind of easy here. This is going to be 2, and this is going to be 1. So that's factoring this trinomial to where now, once we wanting to find the zeros, we can continue doing that. But that's how you factor out the GCF. So when you do those problems, you want to look to see if you can factor out something. Now, the next thing is going to be where now we're going to have, now we're going to look at ax squared plus bx plus c, to where now you have a different coefficient besides 1, and you can't factor out GCF. So back to the original problem that I had before, we had 4x squared plus 13x plus 3. Now I'm going to warn you, you're going to need to probably watch this and write this down and process this a couple of times to really watch what's happening. In the book, they give us to where they have all this guess and check. Sometimes it's easy, sometimes it's going to take forever. So I'm going to show you a method that I learned a couple of years ago that has helped with the amount of time it's taking on some of these problems. So what we're looking for, again, we're going to factor. We're going to find 2 binomials that multiply to get this. Well, you have to think about, okay, we can do 2 times 2, 4 times 1 to get this first one, And then 3 is only going to be 1 and 3, but it's this middle term that always messes people up. So I'm going to show you a way that will stop all this guess and checking. So what we can do is over here on this side, we're going to say A times C, and then this is going to be your B term. So again, remember your A was 4, your A is 4, your B is 13, and your C term is 3. And so what we're going to do is your A times C, but we are actually going to bring this x squared with it. So we're going to take our A times our C, so 3 times the 4x squared, this is going to be 12x squared. The B term, now I know when we talk about B, it's usually just the 13, but I want you to bring the x with it for this purpose. Now what I want you to do is I want you to look at 12x squared. What do we multiply to get 12x squared, but add together to get 13x? So when you multiply 12x squared to get 13x, what two terms that we multiply to get 12x squared, but add together to get 13x? Well, that's going to be 12x and a 1x. Now I'm going to put a 1 here for a reason. But multiplied these will get you 12x, but added together will get you 13x. Now what I'm going to do with this is I'm going to take the 12x and the 1x and I'm going to replace it in for 13x. So I'm going to put 4x squared plus, instead of the 13x, this is going to be 12x and 1x. I'm going to put 12x plus 1x plus 3. I'm bringing down the C and the A term, but all I'm doing right here is replacing the 13x for 12x and 1x. I haven't changed the problem at all, the value of the problem. Now I'm going to do what we call grouping, which now I'm going to group. Usually it's going to be the first two and the last two. And now what I'm going to do is I'm going to factor out the GCF in both of these terms, in both of these polynomials. So 4x squared plus 12x, I'm going to factor out a 4x because a 4x, 4 goes into both, and an x goes into both. So 4x, now when I do 4x squared divided by 4x, I just get x, plus 12x divided by 4x is going to be 3. And then here, 1x plus 3, well, there's nothing else that goes into both of these besides 1. So I am going to factor out a positive 1. And you'll see why here in a second. But a positive 1 to where I still have x plus 3. Now, what do you notice about these two terms here? Notice this x plus 3 is the same, and that's what you want. So now that means I can do 4x plus 1 times x plus 3. So this just factored down to here. Now what you can do is you can check. Now what I would do definitely while you're learning this is to FOIL this or do your box method or your double distributive to check to see if you come back up with this. So I'm over here, I'm going to check. So 4x plus 1, x plus 3, and whatever method you're using is fine. So 4x squared plus 12x plus 1x plus 3. I do come out with what I started with. Okay, so this method really helps. So let's do another one, and we'll do example 2. So example 2 is 2x squared minus 5x minus 7. Now in the book, they have 4 different ways you can do it in the sense of guessing and checking. But once I found out this little method, it has helped tremendously on solving. So now a times c and b. So 2x squared times a negative 7. Make sure you have that negative. Negative 14x squared and a negative 5x. Make sure you take the sign with it. Now, what you're trying to do is what numbers multiply to get negative 14x squared, but then are 5 apart. Okay? So you have to think about negative 14x squared. Well, that's going to be, now it has to be a negative 5. So this can be, I would say, 2 and a negative 7, but both have to be x. So a 2 and a negative 7x. Because if you add them together, you'll get a negative 5x. Okay, so now what I'm doing is I'm replacing this for our b term. So I'm going to have 2x squared plus 2x, that's a positive 2x, minus 7x minus 7. Now, notice what I kind of did was I looked ahead. Like I could have 7x here, negative 7x here, and a 2x here. That's fine. But then I looked ahead and said, oh, it'll make more sense if I have my 2's together in the same and the 7's in the same. So now I can group these first two and these second two. 2x squared plus 2x, what can I factor out? I can factor out a 2x in both of these. So I have x plus 1. Now be careful here. What can I factor out of both of these? Not just 7, but a negative 7. Because I want an expression like this to be the exact same. If I divide negative 7x divided by negative 7, that's a positive x. Negative 7 divided by negative 7, that's a positive 1. Your goal is that these two are the same. Now we have 2x minus 7, and then x plus 1. And then you're done. And you don't have to do all this guessing and checking and moving around. Okay, example 3. Actually, that was example 3. I apologize. That was example 3. Example 4. Notice on this one, this starts with a negative number. The first thing you want to do is you want to multiply. You want the a to be positive. It'll make everything much simpler. So what you can do to get rid of this negative, if you can multiply each term by negative 1. Multiply each term by negative 1. So when you do that, if you multiply all those by negative 1, that turns out to 4x squared plus 8x minus 5. Then we can go ahead. Now, when you do that, I would still make sure you include that negative so you don't forget it. So every time you work it, make sure you know that at the very end, you're going to have a negative on the outside. So now we go back to our AC and B. So now 4 times a negative 5, so negative 20x squared, and 8x squared, or 8x, excuse me. What two numbers multiply to get a negative 20x squared, but add together to get 8x? Okay, so 20, that's negative and that's positive. So we're looking for two numbers multiplied to get 20, but are 8 apart. And you're right, that's going to be 10x and a negative 2x. And one has to be negative because that's negative, but also that's positive 8, so that needs to be a positive 10. Now you're going to replace that in for x, 8x. So negative, so we're going to have, I'm going to kind of hold off on that negative. 4x squared plus 10x minus 2x minus 5. Now, if I notice here, I think I'm going to go ahead and switch these two because the 4 and the 2 and the 10 and the 5. So I'm going to go ahead and switch these. So a negative 2x plus 10x. So if you look at that, and you can do that. Leave this negative out here for a second. Now I can group these two. So I'm going to group. I'm going to still have this negative hanging out. I can take out a 2x. So I have a 2x minus 1. Notice what I can take out here. I can take out a 5, a positive 5, because then I'll have a 2x minus 1. Again, those are the same. That's what we want. Your final answer is going to look like this. That negative on the outside, 2x plus 5, this one and this one, and then a 2x minus 1. And again, always test it, go back and test it. I'm just trying to save time here. So that's how you want to factor these problems here when you have a different coefficient besides when your leading coefficient, that a is not 1. Okay, so I hope that helps. I hope that understands. and we will definitely be doing work day for the next day for sure.